the polar coordinate system. The polar coordinate system. And so what you see on this graph are basically concentric circles. And they're concentric circles based on different radii. So the innermost circle has the radius of 1. And the outermost circle on this particular graph has a radius of, okay, cool. So polar coordinates are written as r comma theta, where the absolute value of r is the radius of the circle, and theta is the measure of the angle in standard position. So to convert to r theta in the polar coordinate system, so we're going from r comma theta to x comma y, we use the rectangular coordinate system where x equals r cosine theta and y equals r sine theta. And you've seen these two relationships already quite a few times. We could say that the x value is located at r cosine theta. And what we've used with the unit circle is r equals 1. So my x value equals cosine theta, right? Well, this is on a concentric circle where r might not be 1. Okay? Yeah, so these are coordinates on the circle. I'm telling you all this was neat. So example 1 says plot the following on the coordinate system, or plot the following on the polar coordinate plane shown above. So here's your tip. Are y'all listening to this? Start with the angle. Start with theta. So this first one says pi over 6. So on this polar coordinate system here, the first sector is pi over 6. I know that because there are 1, 2, 3, 4, 5, 6 of them in pi radians. So I can tell that the first one's at pi over 6. What's the second one at? This one's at pi over 3. This one then would be pi over 2. This one over here, 2 pi over 3. And this one, 5 pi over 6. What'd they skip? Your pi over 4s. They don't show up here. Okay, so just have a heads up that your pi over 4s are going to be between pi over 6 and pi over 3. Your pi over 4s will show up in there. Here's what I learned this morning. You should start with the angle. So start at pi over 6, which is going to be this angle, and we want to go out a radius of 3. So we're going to go pi over 6 out radius 3, and here's my dot. Pi over 6 radius 3. Here's my, let's call this A. I think this is A. Can you see it? Mm-hmm. It's pretty neato mosquito. Let the second one be B. 2 pi over 3, comma 5. So we're going to find angle 2 pi over 3, which puts me on this particular vector. Can you see it? And we want to go out 5. So 1, 2, 3, 4, 5 away. That's going to be letter B. Okay? Letter C. This one threw me. This is where I had to get out the YouTubes. It says negative 4 comma pi over 4. So we know pi over 4 is going to be on this angle between pi over 6 and pi over 3. Yeah, but instead of going to positive 4, we have to go 180 degrees to negative 4. So that's going to actually land us here. 1, 2, 3, here. Negative 4. Okay? So you go to the angle that it says, but then if your R value is negative, you flip 180 degrees and land in the opposite quadrant. Does that make sense? Okay? I learned that the hard way. That's why I'm telling you go to the angle first, and then if you have a negative, then you're going to rotate all the way around the axis. So letter D, if I go to negative 3 pi over 4, that means I'm going to count backwards. I'm going to count in the clockwise direction. So 1 pi over 4, 2 pi over 4, 3 pi over 4, and I'm at 4 away. What does that mean about D? It's the same point. Same exact point as C. Did y'all see that? So for negative 3 pi over 4, I count backwards. 1 pi over 4, 2 pi over 4, 3 pi over 4, and we're at radius 4 away, so that puts me at the same exact point as C was. So two different ordered pairs land in the exact same position on this polar grid. Are we good? Any questions? No questions, really? Okay. Example 2 says convert the polar coordinates to rectangular coordinates. So the rule on polar to
Students, if you signed up for a calculator for the ACT test.
Okay, so the rule on converting from polar to rectangular is this. Polar to rectangular, x. So x is rectangular. X is equal to r cosine theta. And remember that your polar coordinates are given as r comma theta. R comma theta.
That's an almost fully charged calculator.
Whoa. So your x value is going to equal 3 times cosine of pi over 6. What is cosine of pi over 6? So we have 3 times square root 3 over 2. That simplifies to 3 square root 3 over 2. That's your x coordinate for your rectangular coordinate pair.
You replace it with sine for now.
You need the y one, so that's going to be sine theta. So you'll have 3 times sine of pi over 6. What is sine of pi over 6? So 3 halves will be your y value. So that's your ordered pair. No. All right, letter B. Same thing. Convert the polar to rectangular. So for x, we're gonna have 4 cosine of 3 pi over 2. 4 cosine of 3 pi over 2. What's cosine of 3 pi over 2? 0. So 4 by 0 is 0. For y, we have 4 sine of 3 pi over 2. What's sine of 3 pi over 2? Negative 1. Perfect. So what's the ordered pair? 0, negative 4. No trouble here? Arcsine. Arc10, actually. Okay, so on the next one, it says converting rectangular coordinates to polar coordinates. For the r value, it's Pythagorean. The radius is found by taking the square root of the x squared plus the y squared. It's Pythagorean theorem. It's a circle, right? And I can find the radius, r, by doing x squared plus y squared equals r squared. And if I square root both sides, I got r. That's pretty clear. Theta is tangent inverse of y over x, sine over cosine. Okay? If x is greater than 0, so if your x value is positive, you stop right there. If your x value happens to be negative, you add pi. 2 rules. If x is positive, it's just tangent inverse of y over x. If x is negative, you have to add the pi piece. Okay? Now, one rule that you have to keep in mind. Tangent inverse of x is bound. Inverse of x is bound between, anybody remember?
It's your 2 pi.
Negative pi over 2 and positive pi over 2. So we only look at the right side of the circle for tangent inverse. Okay? That's going to be important. It's bound. That's because we catch all of tangent between negative pi over 2 and pi over 2. we catch the entire graph between those two values. We account for all of the y stuff. Y'all remember learning this? This is like 3.9 or something like that. Yeah. Okay, so we're going to convert the rectangular coordinates to polar coordinates. The first thing we got to find is r. And r is equal to the square root of x squared plus y squared. In this case, that's going to be the square root of 3 squared plus negative 3 squared, or the square root of 18. 9 plus 9, 18. Simplify. 3 square root 2. Okay, so there's our r. That's the first coordinate of our ordered pair, right? The first piece. That's the r piece. The theta piece comes by taking tangent inverse of y divided by x. That's going to be negative 3 over positive 3. X is greater than 0, so we don't say plus pi. We leave it alone. Tangent inverse of, what is negative 3 divided by positive 3? Tangent inverse of negative 1, bound between negative pi over 2 and pi over 2, what is that? Say it again.
7 pi over 4.
Right, 7 pi over 4, but between negative pi over 2 and positive pi over 2, what would we call that? Go backwards.
Oh,
Negative pi over 4. Okay, so that's where this comes into play here. You know it's at 7 pi over 4, but you've got to put that on this grid. So that's going to be at negative pi over 4. Okay, do we understand that? So your y value here would be negative pi over 4. There's your coordinates. Good. Okay, let's try the next one. R is going to equal the square root of negative 3 squared plus 4 squared. Right? 25 in there. It's a 3, 4, 5 triangle, so we hope that R is 5. So R equals 5. And then we have tangent inverse. Theta equals tangent inverse of 4 over negative 3. So this time, x is negative, so we add pi on the end of that. You cannot simplify tangent inverse of 4/3. You don't have a unit circle value or an exact value for that. So we just call it 5 comma tangent inverse of 4 over negative 3 plus pi. Yeah, you. I don't know how to plot that, but that's good enough.
as long as they count, that's all that matters.
I know. All right, do you have your calculators? Can you get your calculators out right now, quickly?
2.2 work quickly.
If I was looking at an ordered pair, how would I know if it was polar or rectangular?
If it has a theta value in the y.
If it has a pi something in the y value, it's probably polar. Just by looking at it, if I see pi, it's probably polar. Because that angle measure is usually got a pi in it. Okay, so if I see pi, I'm probably looking at polar. Here we want to convert polar to rectangular. And we want to do that using our calculator. So R is going to equal 2. So our x value is going to equal 2 cosine pi over 5. R is 2, theta is pi over 5. X is going to be 2 cosine of pi over 5. You want to be sure you're in radians. And we want to round to 3 decimals. Did you type it? 2 cosine pi over 5. What'd you get? Good. And our y value is going to be at 2 sine of pi over 5. Uh-huh. So our rectangular coordinates here would be 1.618, comma, 1.176. Not too bad. Okay. The second question says convert the rectangular coordinates to polar coordinates. Still using our calculator. And this time I have r equal to the square root of x squared plus y squared. Or the square root of negative 5 squared plus negative 12 squared. 5, 12. What's the... Anybody recognize it? It's a special right triangle? 13. 5, 12, 13. Named it scalene, something like that. So this is a 13. And what's theta? Theta is going to be tangent inverse of y over x. X is negative here, so plus pi. Put that on your calculator. Tangent inverse of negative 12 over negative 5 plus pi. You could probably just put 12/5 and not put negative 12 over negative 5. If you put both of them, you're fine. That's what I said. You could either put both of them or put neither of them. But you know that x is negative, so you have the plus pi on the end. $4.318. 4.318. Yeah? Not bad? What's this mumbo jumbo on this side? Yeah. Okay, so this is complex numbers. These are complex numbers. It says a complex number. Okay, so give me one letter that would represent a complex number. I. Okay, I. So that's what we're dealing with here. We used to have a plus bi would be a complex number. It would combine a real and an imaginary portion. Okay? So determined by the rectangular coordinates AB, where A is your X piece and B is your Y piece, you can still do that in the polar coordinate grid. It says a complex number in the complex plane can be determined by polar coordinates r theta and expressed as r cosine theta, which would be your X piece, plus I times r sine theta, which would be your Y piece. You might see r cosine theta plus I r sine theta written as r cis theta. I have never before seen this in my life. Okay, so confession, that was brand new to me this morning. It wasn't bad. I could do it, but I'm not familiar with that. Huh? Okay, so I wanted to work through how did they get from this number right here to this number right here. And in my mind, it helped me to kind of walk through that before I tried the example. And we've got time to do that, okay? So this is 2 minus 2i. Everybody with me? 2 minus 2i. What that means is your x value is 2. And your y value is negative 2, right? So r is found by taking the square root of 2 squared plus negative 2 squared. This is 4 plus 4, so square root of 8. So square root 8 we could call what? 2 square roots of 2. And then theta is going to be tangent inverse of 2 over negative 2. Right? 2 over negative 2. Actually, negative 2 over 2. I was about to say. I didn't like that. Negative 2 over 2. That's better. So we don't have the plus pi piece, right? So tangent inverse of negative 1 on the interval from negative pi over 2 to pi over 2 is going to be negative pi over 4. That's our theta. So if you can get those numbers, you can see where they place them. In the beginning here, there's your r. And then your argument is theta here and here. Okay. Once I kind of walk through that, I can handle this in next example. Negative pi over 4. Yeah, I got a negative sign. Okay, so let's look at the example. It says, express the complex number negative 3 minus 3 square root 3I in polar coordinate form. Okay? So, if I'm given this information, it's my responsibility to recognize a plus bi and be able to pull an x and a y value from that. So, what would a be?
-3.
Minus 3 square root 3i. So, a, or x, is going to be my negative 3. And my y value is going to be negative 3 square root 3. Okay, we can do this. So, now let's start by finding r. And r is going to be the square root of x squared plus y squared. Or the square root of negative 3 squared plus negative 3 square root 3 squared. Everybody okay? Yep. I thought I was getting out from under you. You good? So the negative 3 squared, 9, right? When I square this product, I square both pieces. So the negative 3 gets squared. That makes a 9 times square root 3 times square root 3. That makes a 3. So I have a 9 plus a 27, which is 36, and the square root of 36 is, there's r. R is 6. Y'all okay with this? Look at me. Did we get there? Everybody good? Theta is tangent inverse of y over x. So negative 3 square root 3 over negative 3 plus pi. Because why? Because x was negative. But those x's cancel, right? The negative 3's do cancel. So really, I have tangent inverse of square root 3 plus pi. Now we've got to think. What is tangent inverse of square root 3? That means that the sign had the square root 3 in it. So it was tall. So it's a pi over 3. It's positive. So that means we're in quadrant 1, as opposed to being in quadrant 4, right, which would have been negative. So we're in quadrant 1. That's pi over 3. So theta is pi over 3 plus pi, which is 3 pi over 3. So pi over 3 plus pi tells me that theta is, 1 pi over 3 plus 3 pi over 3. 4 pi over 3. So we've got r is 6, and theta is 4 pi over 3. So are y'all ready to try to write this out? In this form, we're going to have 6 cosine of 4 pi over 3 3 plus I times 6 sine of 4 pi over 3. And I want to talk to you about a couple of different things that could happen. They could recognize that both terms have the 6, and they could pull it. So you could see 6 times cosine of 4 pi over 3 plus I sine of 4 pi over 3. These are equivalent. Rookie mistake would be to pull out the 4 pi over 3. I see that from kids who don't know anything about trig. You cannot separate the argument from the trig function. Okay, that's a rookie mistake. You look at that and you say, hey, both have a 4 pi over 3, and yank it out of there. Wrong. Bad. Don't do that, ever. Okay. The other form that you might see here is to say 6 CIS 4 pi over 3. Also equivalent. That's cosine I sine 4 pi over 3. Any questions on that? All three of those are equivalent. Did you understand how we got r and theta? You understand that we had to add pi to pi over 3? Why? X was negative. Okay? Guys, your homework goes with this lesson. It's nice. I did it all this morning, and I thought it really went well together. Okay? Don't just decide, I don't ever have homework in this class. That's ridiculous. Yes, you do. And you have lots and lots of lessons to do. Okay? All right. Fare thee well.